Okay, everybody, we are on our next day. We've had a 3-day holiday, and we're about to do geometric sequences, and you also had a lot of review stuff today because we're getting ready for a test at the end of this week. So on Friday of this week, we are taking a test on Unit 2. So remember, all these lovely Unit 2 posters that are behind me are in your resources key on the very home page of your algebra classroom. So when you go in and look at the home page, there's a button that says resource. If you click on that, you will see all these lovely posters, and I would suggest that you go in and take a picture with your phone so you have them to look at while you're doing the worksheet. It will make it much easier. Okay, so we did arithmetic sequences last week, and of course arithmetic is when you were adding and subtracting to get to the next term. A sub 1 is your first term, D is the number that you're adding or subtracting. And then we had an explicit formula that would allow us to find any term by jumping to it instead of having to make a big long list. Geometric sequences are very similar. Here's my lovely sequence, 15, 30, 60, 120. That time we're multiplying by 2. So anytime we are multiplying, it is going to be, let me get it back here where we can see a little better. Anytime you're multiplying, it will be a geometric sequence. So they call this an R, not a D. So if they give you a lowercase r, that means it's geometric and you're multiplying by that. It's called a common ratio because if I take 120 and divide by 60, take any term, divide by the previous one, you'll see what you're multiplying by. So that's why you can find out what the R is when you can't just see it, visually see it. A sub 1 is still the first term. 15 was the first term up there, so nothing changed. A sub n is what they're asking you to find. So if they're looking for the third term in this particular sequence, A sub 3, if you count 1, 2, 3, it is a 60. Okay, so all that is still the same. It's just that it's R and it's a multiplying. The explicit formula is again very similar. So down here's my explicit formula. I can find any term by substituting in the first term, A sub 1, and then the math number. This time it's a times R. Sometimes they'll put it in parentheses because it's not a plus or minus, it's a times because this is a multiplication sequence. And now the n is an exponent. So this parentheses is small and raised up high. It is an exponent. So don't make it big in the same line down here as the rest of this. This is an exponent, it's raised up high. Okay, so that's how you find any particular term. And of course, the recursive formula down here is only good for them to show us the R. They will give us this when they want us to see what the pattern is as far as what are we multiplying by. So let's go do a few problems. Now on your warm-up today, you had some lovely attributes where they gave you the pictures of the linears and pictures of the quadratics, and you were looking for those parts. And so we don't want you to forget that because that's going to be a big part of the test. So here's that linear poster. Let me get over here where I can see it. And of course, remember, x-intercept solutions and zeros are all the same thing. So if they're asking you for a 0, you're looking for the x-intercept. And the y-intercept is where it's crossing the y-axis. Let's see what else will be on there. Oh, yes, our quadratic equations. So here's the quadratic equations. The very tippy point where it changes direction is your vertex. And that vertex can either be a maximum or a minimum. If it's a high point, it's a maximum. If it's a low point, like up there in the corner, it is a minimum. Where it crosses the x-axis are still your x-intercept zeros and solutions. Where it crosses the y-axis is still your y-intercept. So all those points will be on the graph, and so we want to make sure that we remember how to do them. The imaginary line down the middle is still called the axis of symmetry. Now, if you have an equation that is in standard form, you may need to convert it back to y equals so that you can put it in the calculator. So remember, I have this lovely poster at the back of my room, and for those of you at home, you might want to take a picture of this too and have it handy. But it step by step takes you through changing something from standard form to y equals. You get rid of the x term first, and you cannot add the 6 and the negative 3x on the right side, so you write them side by side. And then you come back and divide by your number that's with the y, and you split it up over here and reduce those fractions. And if they can be reduced, you reduce them down. So there it is step by step on how to solve for y, because we don't want to forget how to do that, because they will give you, sorry, the bell's ringing. They will give you the equation in this format, but you cannot put it in the Inspire calculator. You have to change it to y equals before you can put it in, and then go look at the picture and answer whatever question that they're asking. Okay, so back to today's worksheet. After you did all the attributes, picking those lovely things out, and hopefully it all came back to you. And again, look at the posters because we want you to learn it by looking at the posters. The next thing that's in the worksheet is some review stuff. And that one is, blow these up bigger. Hopefully they're going to show up. Domain and range. So don't forget in your posters, domain are the x's and range are the y's. X comes first in the alphabet. D comes first in the alphabet. Y comes second. Range comes second. Okay, so if you, I don't know if this is still big enough. Let me blow it up as big as it'll get. So I'm going to look at number 2 in this picture. So the directions on this one says, the graph of a linear function is shown below. So there's a lovely picture. And the question is, what is the domain? So I underline the word domain because that's what I want to focus on. So hopefully when you see that word, you're going to put a big X to remind yourself, I am looking for the X numbers, not the Y numbers. This is multiple choice, so come down here. If we're looking for the X's, should I pick any answer that has a Y in it? No, get rid of those answers. Don't even look at them. Don't even be tempted to pick one of those answers. So there's only 2 answer choices to choose from. Now don't get freaked out because you see some extra X's in here. This is just another way that different mathematicians will write their little fancy shortcut. And this is just X's such that X's are between -3 and 1. Now this one is also between -3 and 1. So both of these are identical except one has a line with this one and no line with the second one. This one has no line with the first one, but a line with the second one. So remember, when you're doing your X's, you're going to crop in, focus on the X-axis, focus in on the furthest right and furthest left. So I have these 2 numbers circled. I have a 1 and a -3, and those are my 2 numbers. The X's are all between those 2 numbers, -3 and 1. And then you have to decide if it's going to have a solid a line with it or not. If it's a solid circle, that -3 should have a line with it. If it's an open circle, that 1 should not have one. So G was the correct answer on that one. So remember your open circle and closed circles if they're going to have a line to be equal or not. So you have that whole first side that you're going to do for domain and range because a lot of the test is domain and range. And we're just picking them out of multiple choice answers. Now over on the right hand side of this worksheet, we're doing the same thing. And we're going to look at number 5. So here on number 5, and I hope these are, is it number 6? Maybe no, it's number 5. I want 5. There we go. Again, they say the graph of a linear function is shown below. What is the domain of the function? So as soon as you see the word domain, I hope you write a big X here to remind yourself we are looking for the X's. Then I come down here and I look, are there any things with Y's in them? Oh, well, by golly, there's a Y. Get rid of that answer. Domains do not have Y's in them. So I got rid of one of my answer choices. Don't even pick that one. Now, these are individual dots. Remember, individual dots is our discrete data, D for dots, D for discrete, which means I just want that X number, I want that X number, that X number, and that X number. So they're all going to have little commas between them. So if I look at the 2 answer choices down here, these all have commas, but this one does not. That would not be it. That would be the way I would describe my continuous data when I want all the points, and there's too many for me to list. Now I just need to pick out these points. X numbers, make sure you are focused on the X-axis. These are the numbers I'm circling. This one comes up to a -1, that one's a 1, that one's a 2, and this one is a 4. So make sure you're circling numbers on the X-axis, not accidentally circling this 5 up here, because 5 is not in my X-axis, so do not pick that one. Make sure you're circling numbers on the X-axis because it's domain. And of course, those numbers are B. So just double check and make sure that you are doing what you're supposed to be doing and focus on those numbers only, all right? Sometimes highlighters will help with that. Sometimes you can just draw a big circle around those to remind yourself, pick only those numbers. Don't pick them on the Y. Now, the other one we want to look at is number 7, simply because they've done the answer slightly different. They gave them in words. So I didn't even read the top part. I found the question mark down here after the graph. It says, what's the range of the situation? I have a picture. I could care less about the words above. I have a picture. I'm finding the range. Hopefully you wrote a big Y right here saying I want the Y's, which means I am focused on these numbers. Okay, I'm not looking for 0 through 10. I want these numbers, 0, 20, 40, up to 200, and so on, right? So here's my lovely picture. I come up from the bottom, so I want Y numbers. I crop it from the bottom and it touches 40. And it stops there. It never goes below 40. But when I come down from the top and look at the top of this graph, there's an arrow, so it's going to go up forever. So I want all of these Y numbers above 40. I just need to figure out which answer matches that. So the first one says all real numbers greater than or equal to 0. Did it come down all the way down here to 0 to go up, or did it start at 40? Yeah, it started at 40, so don't pick a negative 0. My number's at 40. There is no 0 in my thing. It's a 0 and a Y. All real numbers greater than or equal to 40. I'm kind of liking that one right now. We'll check next to it. All real numbers less than 220. Does it start here and go down forever? No. All real numbers less than 9. well, I don't think, 9's not even really in my focus over here. I want 40 and bigger. 9 would be coming down from this. So if someone picked that one out there, they may have done that. So that one didn't make any sense to me at all. But all real numbers greater than or equal to 40, because it was a solid there. That's why they put or equal to. So B was the right one on that. So sometimes they do it in words. Sometimes they'll do it in symbols. Either way, you're just looking at the picture, making sure that the words match what you see on the graph. Okay, so I'll leave the rest of those for y'all to do. And remember, you always have the answer key to check when you're working those to make sure you're getting them right. And you want to check because you need to know if you're missing any. Okay, if you're getting them all right, that's great, but you're not going to know that unless you check. And if you're missing some because your thinking is totally off on something, you need to know that so we can fix it before the test. And the test is coming up. Okay, so today we're focused on geometric sequences. We did arithmetic last week. And we talked about geometric before we started all this lovely stuff here. So let's go do some of these. You have 4 problems where you're solving equations. So make sure on 3 and 4 you're using that poster that I pointed out in the back of the room where you're going from an x and a y, solving for y, getting it in y equals form. So use that poster, make sure you're doing it right. You must show your work on those 4 solving problems. You have 1, 2, 3, 4 where you are solving problems. Okay, on that first page, 1, 2, 3, 4 right in here. Show your work on your paper. If you don't show me any work, you don't get points for those questions, okay? And then check them against the answer key, make sure you have them right. Okay, so now I'm at the bottom, geometric sequences. Here we go with the geometric sequences. The directions on number 15 say, given the first term, so I know the first number in my sequence of numbers, and the following recursive formulas, they want us to find the 7th number or the 7th term in my string of numbers. So since it's only the 7th one, I'm thinking I can just make a list and just go count over to 7. Sometimes old school, low tech is the easiest way to do it and not make a mistake. So a sub 1 is my first term. Whether it's arithmetic or geometric, a sub 1 is the first number, so here's a 3. Now here's the recursive formula. Notice a sub n is equal to a sub n minus 1, same in both formulas, but this time it's times negative 4. So it's not an add subtract, it's times negative 4. So my math is I'm multiplying by a negative 4 to get the next number. So this is what that recursive formula shows, is the math. You are multiplying times a negative 4 over and over. So if you take 3 and multiply times a negative 4, and you can put that in the calculator, you get a negative 12. Now, when I put negative 12 times negative 4 in the calculator, now I have 2 negative numbers being multiplied together, and the answer is going to be a positive number. And 4 times 12 is a positive 48. So negative times negative is now positive. But now I have a positive number times my negative number again, and when the signs are different, it winds up being a negative number. So 4 times 48, and I don't know that I have the answer key handy on this one. I guess I could just multiply this. These are going to get to be really big numbers. So I'm going to grab my calculator, and I know in just a second it's going to get beyond me wanting to do this by hand. So 4 times 48, that's 192. But since one was negative and one was positive, that's a negative 192. So notice it's going from positive to negative, just because you're multiplying by a negative number. All right, so then I have a negative 192, and now it's going to go back to negative times negative. It's going to be a positive answer. So 4 times 192. 768. So negative 4 times negative 192 gave you 768. Now I'm going to multiply it times a negative number, and I bet it goes back to negative 4 times positive 768 is going to wind up being a negative answer. So negative 4 times 768 equals negative 3,072. Oops, 3,072. How many do I have? 1, 2, 3, 4, 5, 6. I still need one more number. I'm going to put a little tiny comma there. And so I need one more. So negative 4 times that 3,022. 3,022 times 4 equals 12,088. And this one's a negative. So positive, negative, positive, negative, positive. Ooh, that one should have been negative, which means this one is my positive. So I'm kind of double checking my math here. So negative, positive, negative, positive, negative, and positive. 1, 2, 3, 4, 5, 6, and 7th number. So there is the 7th term in that. So that's what you're doing over and over in this one, is they give you the first term in the formula, the recursive formula, they show you're multiplying by something. And so that tells you your pattern. So you're just writing the numbers down and then coming up with that particular pattern. Just write the numbers down and count over to the 7th term if you're looking for the 7th term. So that will take care of 15, 16, 17, and 18. You do all those the same way. And then on the back, we're gonna make some little tables. So we're gonna do 4 of these on the back, and surprisingly, these numbers get really big really fast. So don't be surprised when you get some really huge numbers when you're looking for the 9th or 10th term. Let's see. We're only gonna do 3 of these on the back, so it's once you get 3 done, you're done. We're gonna do 1 together, and then you can do 2 on your own. So a sub 1 is -4, so my first term is a -4. And the math is 6. So r is a 6, meaning you're multiplying by a positive 6. So 6 times 4 is a -24. And then 6 times -24, I know I should keep that calculator handy. 6 times 24, -144. 6 times -144. 864, so -864 times another 6, -5,184. So you're just filling in that table, and each time it's getting bigger by 6. Actually, they're getting smaller by 6 because these are all negative numbers. So they're getting further and further negative, further away from 0. Checking this real quick. 24 times 6 equals, times 6 equals, times 6 equals. Yep, okay, so we're good. Now, explicit formula. That's the one that finds any term. It's still a sub n is equal to the first term, which is the -4, times r. So you could do the dot, or I would put it in parentheses just to make sure I can see it. And then up here in small, it's n minus 1. So there's a little n minus 1 is the parentheses up there. So this is the explicit formula for this particular pattern. You can see the starting number and you can see the times 6. Now, they want you to find the 9th term, which means I'm looking for the 9th one, right? So that's what that means, is the 9th term. So I still have -4 times 6, and then this 9 is 9 minus 1. Now, rather than putting 9 minus 1 in the calculator, could we just go ahead and do the math and say 9 minus 1 is 8? So when you get ready to put it in the calculator, you're going to have a little 8 there. Now, when you go into your scientific calculator, you just need a scientific calculator that has parentheses. So we're just doing the math on the side. You're going to put in the 4. You're going to change it to a negative by punching that little plus or minus symbol, so that now it's a -4. So you put in the -4, and then you can put in a parentheses for times. I think you have to put times. I would go ahead and hit the times button, okay? So times, and then parentheses, put the 6 inside. After the parentheses, you need that little rooftop key. It looks like a little rooftop, kind of like this, little rooftop, and it's above the number 6. So in order to get to that rooftop key, what you have to hit is Shift and then 6. And what that does is it puts this little rooftop key in the calculator, which is telling you to raise it to a power. So you put the 4, change it to a negative, times parentheses, 6, close the parentheses, then Shift 6, puts this character in, and then all you type in is the number 8. And that puts this in the calculator, so you can hit enter and it will tell you the answer. And it's going to be a pretty big number. And I wish I had my answer key handy here. I thought I had it with me. What did I do with it? Oh, here it is. Here it is, here it is, here it is. Okay, it's a really, really big number. So the 9th term is, it's a -6,718,464. So it got really, really small in a hurry. We're at the 5th term, and that's the 9th term, so it's just 4 more terms down the list. So that's what you're doing on these. So remember to do this little exponent. It's Shift 6. That gives you the little rooftop key, and then you can type in the 8. So know how to use that scientific calculator. All right, and you're doing the same process over and over. Some of the numbers are really, really funky. You just need to do 3 on this page. Any 3 you want to do. We've already done 1, so 2 more. All right, that is it, guys. Y'all have a wonderful time tomorrow. The next 2 days we are reviewing for the test, and test is on Friday.